let's talk about the internal components of master node. Okay, so in a master, what are all the components are available? Okay, so the first and foremost component in the master is called Kubernetes API server. Okay, so this component is responsible for the communication. Whenever you want to communicate to the cluster, you will be communicating it via the API server. Okay, and that is the only method you can communicate to the Kubernetes cluster. So the core component of Kubernetes, one of the core component of the Kubernetes is called Kube API server. This through this only Kubernetes will communicate to the end user, and also the node also will get communicated to the master using the API server only. Okay, and the next core component of the Kubernetes is called etcd. etcd is a NoSQL kind of database application. Okay, so which basically stores the value as a key value pair combination. Okay, and all the configurations of the cluster, all the applications which are deployed on a cluster, all these informations are stored in the etcd. So if you literally migrate the etcd of one cluster to another cluster, it is equivalent to the migration of the complete cluster. So etcd holds the complete configurations of the cluster and also the applications running on the cluster. Okay, and next important component in the Kubernetes master is called Kube scheduler. Right? Whenever I want to schedule some activity on the Kubernetes cluster, Kube scheduler is responsible doing that. And in Kubernetes cluster, you are allowed to run batch jobs, okay? And you are allowed to run some of the other activities also. So using Kube scheduler, you will be able to schedule the batch jobs, and some scheduling activities can be happened, okay? And another important component in the Kubernetes master is called Kube Controller Manager. Kube Controller Manager is the captain of the ship. Any decision which has to be taken on the cluster will be taken by the Kube Controller Manager. Okay. When you give an instruction to the Kubernetes cluster, you will give it to the API server. API server will hand over the instruction to the Kube Control Manager. Kube Control Manager will analyze it and it will perform the required activity. Okay. So these are all the four mandatory components for a Kubernetes cluster. One is Kube API server for communication, etcd for storing the configuration, and then Kube scheduler for scheduling activity, and Kube control manager is the core service which manages the complete server or complete cluster. Okay, and adding to that, there is one more component called cloud manager. So cloud manager is something which you can use it to communicate to the cloud resources. Like for example, your Kubernetes cluster has to communicate to a cloud service provider to provision some storage for your containers. Like you are attaching volumes to a container, right? So it has to communicate to the cloud to allocate a volume, and that volume has to attach to a container. So for those kind of activities, this cloud control manager can communicate to the cloud service providers. And also when you are exposing the service, okay, so I am creating a microservice and I have to expose this as a service. So I need to expose this to the external world via some load balancer or some other method. So my Kubernetes can communicate to cloud load balancers. Like for example, in Amazon, we have ELB, Elastic Load Balancer. In Azure, we have Load Balancer. And also we have, in Google, we have Google Load Balancer. So my Kubernetes can communicate to these cloud providers and it can expose my application to the external world via load balancer. So for these things, you need the cloud controller manager. So these are all the major 5 components in the master. And in the node part, there are 2 major components which is needed. One is called the kubelet. Kubelet is the component which will communicate to the master via the API server, and it will receive instructions, and that instruction will be executed on the node. Okay, so kubelet is the client which will be installed on the node, which is responsible to connecting to the Kube API server. Sorry, that is Kube master. Okay, and adding to that, there is one more core component called Kube proxy. Okay, Kube proxy is something Imagine in the networking, I have talked about overlay network, which allows communication between container to container, right? On top of the existing physical network, I will be communicating, I will be creating one more virtual network called overlay network. So that will be allow container to communicate to the another container. So that is where this kube proxy comes into picture. This kube proxy facilitates the communication between the containers. Okay, and kube proxy cannot on its own will not be able to do that. So it needs some of the network providers. Okay, so while talking about Docker network itself, I have talked about there are various network providers available for Kubernetes, right? So, okay, so this is the link on the left hand side. Sorry, on the right hand side, you can see various network providers are available, right? So every network providers has its own advantages and there is some limitations for that, right? Like for example, if you see Azure CNI for Kubernetes, this is specifically if you want to have your Kubernetes cluster to communicate to Azure network, then you can use this Azure CNI. For example, if you have your, either you can have your Kubernetes cluster on Azure or the Kubernetes cluster is in on-prem and it has to communicate to Azure, then the network provider which best suits is Azure CNI. Okay. And then like the same way AWS, okay. And a big cloud fabric for big data and those kind of areas. Okay. And like that, on general, there are very commonly used network providers like Calico, okay, and there is something called Flannel, okay, this Flannel and this Weave. These are very well used in a normal application deployment strategy or a scenario, okay. So these are all the very widely used network providers. So based on your requirement, you have to choose which network provider will choose better for you. These are all the two components which are most needed in the node. One is kubelet and kube proxy. On top of kube proxy, I will have this network providers installed. Okay, we will see a detailed explanation of a Flannel and the Calico, how they are working, and we will see how the communication, how these two are different and what is the advantage of one network over the another one. We'll see that example. Okay, and next thing is the containers which are running in Kubernetes are called as pods, POD. Okay, and you can say that okay, a pod can be a single container pod or a multi-container pod. Okay, so a multi-container pod will be something come into picture. Like we are going to talk about a concept called sidecar injection. So the why we'll use the sidecar injection, we'll talk about that. Or otherwise, let's take a normal scenario example. You are running a database container, right? In the database container, what we have told at the 12-factor app development principle, if they're having any backups or backing services, don't run it on the same container, right? So what we will do, we will inject another container in the pod saying that every day at 9 o'clock, I want this database to be backed up. Then I will attach another container to it and I will expose that. This is one kind of scenario. And another kind of scenario is like there is something called as a init container. Init container will be used something like, let's say your container will take at least 2 to 3 minutes to bring up the services completely. Okay, till the time you want to tell there is some containers you want to run, and it should register the service only when the service is completely up. Then you will use some concept like a init container, which can do those kind of jobs for you. Okay, so those kind of things you can are examples of running a multi-container in a single pod. Okay, so in Kubernetes, all the running containers are called pods. The pod can have single container, or these kind of special scenarios, you may also have a multi-container pod running on it.